Hey guys, so today we'll be solving the question called valid parenthesis string, right? And the question says that we are given a string containing three characters, this so and so, and there is an opening bracket, there is closing bracket, and there is a star character. Now, what the star character indicate is that it can be treated as a closing one or opening one, or it can be treated as an empty string. Now you have to return whether it's possible to take this string and represent a valid parenthesis using the string or not. And that can be, let's take this example. Let's take this example and tell you that. So in this example, right now it looks invalid, right? Because we have more number of closing brackets. So we can take this star and try to interpret it as a opening bracket, right? And that means that the whole string would have become valid, right? But guys, let me ask you one thing. How many times you do the lead code questions and then you ask yourself that, hey, where I'm going to use this knowledge after getting placement or after even solving this given question, after spending all those hours where you could have played, you could have spent time with your friends, you could have gone partying, you could have enjoyed all the weekends, your friends, and I don't know what, played on a PS4, watched TV. You could have done every single thing. But where does problem come useful? And this is what it hit me. This is what it exactly hit me, because guys, we as a programmer, we as a developer, we spend a lot of energy in preparing for these interviews, and sometimes the interview preparation is very mind draining for us, right? I mean, so that's why I thought ki, why can't we just utilize the lead code knowledge and just keep it in a format where in future we could eventually solve these kind of questions, right? And this is where I came with an intuitive approach, and let me tell you that. So I'm going to reimagine this problem for you. I'm going to reimagine this problem for you. So we are going to take this problem and going to convert into a drone problem. So now instead of a string, we have a series of log. We have a series of log. Now let's say that you were flying a drone from an altitude of 0, right? And after that, you lost the signals, right? After some point, you stop receiving the signals from the drone, right? Now you checked your computer. Now you checked your computer, and now you realize that you received three kind of signals, right? You received up, you received down, or you received some corrupted signals, right? That so up means that the drone would have moved up 1 unit, or down means that the drone would have descended 1 unit. Corrupted signals is a very tricky thing over here. Corrupted signal is something which says that the drone might be some noise, right? It might be some noise which you need to ignore, or it might be some up signal, or it might be a down signal. So this is the exact thing which you need to take care of. And now, yes guys, we have totally turned this problem upside down. Think out of it actually, right? You are flying a drone. Let's say that you are flying a drone, and after some point you lost the sight of the drone itself, but you know the signals exist. But you might ask me what I will do with this question, what I will do this. Again, Aniket, you're trying to trick me into another loophole. But no guys, wait. Here comes the banger. Now your task is to determine whether it's possible that your drone has never crashed, right? And the drone returned to a ground level at the end of the flight. That is at the altitude of 0. Now why this is important to us? Because after interpreting the signals, if you are somehow able to convince that, hey, it's possible that the drone has never crashed and it returned to the ground, that means ki I can go and retrieve that drone, and the drone might be in a good condition. Think of it, the drone might have some safe conditions to land back, right? And before landing back, it transmitted all the signals to you, right? Now you're interpreting the signals, and now you're trying to make a sense that should you begin your search operation or should you abandon all your hopes. So this is where this problem comes very handy. Now I know that we were started with a valid parenthesis string question, right? But what's fun in that, guys? Let's be honest. That's a very boring interviewer question. I don't even want to read that problem, to be honest. So let's get started. So with this problem statement clear, I'm going to present something over here. Now instead of opening and closing brackets, again boring thing, I'm going to use an U character for the up signal and D character for the down signal, right? And the corrupted signal is going to be represented in the form of a star. Now note guys, the corrupted signal can mean noise as well. It can mean noise as well. It can mean up as well, and it can mean down as well. Now you can interpret this corrupted signal in many different ways. If you try to interpret as a noise, that means you need to ignore it, right? You do not need to consider it valid move. That means you can ignore it. So for example, let's take this very basic example. This means ki up down star, right? Now if you had interpreted the star as down, that means your drone would have effectively crashed, because the drone would have gone up, the drone would have gone down, and if you interpreted the star as a down thing, then it would have crashed. Otherwise, if you had interpreted the star as up, it would have indicated that your drone is still in the air, right? Your drone is still in the air. But what's the fun in that? I mean, we just want to see whether it crashed or whether it never crashed, or and if it returned to the ground station, right? So that's why we're going to choose to ignore the star, and this would tell us that hey, your drone has returned safely to the ground level, and you can just go and begin your search operation. This is one of the possibility, guys. Let me tell you that it's not a guarantee, it's one of the possibility. And why this possibility is important to us? Because if the drone, let's say that somehow you detect the signals. Now, why this is very important to us? Somehow you made a sense of the signal, right? And you detected that whatever sequences you follow, whatever interpretation of star you put, you discovered that the drone always crashed. That means why to start your search operation? Why to even start your search operation? Right? It makes sense also now. If you interpreted the signals in such a way, right now this is a good scenario. Right now this is a very good scenario. Let's say that you have a particularly bad scenario in which all the possibility were against you, and the drone has effectively crashed. So that means do not begin your search operation. You can sleep peacefully. At least you know that you do not have to do any extra efforts. Yep. So let's get started, and I'm going to tell you the intuition. I'm not going to keep you waiting. The intuition behind this problem is that we are going to use the altitude checker, right? So the thing is that you might think that we need to try every single possibility of this given star, but that's a very trivial approach. I mean, how many different possibilities can actually? There are 3 different possibilities, and who's gonna waste time? There will be 3 to power n cases if there are n. Actually, if there are any, if all of them are noises, then there are 3 to power n cases, right? Just in the worst case, I'm just trying to highlight that there can be a lot of exponential cases which you might need to handle, and you need to be very careful around that. So we need to come up with a very fast and efficient approach, because remember guys, if the drone has not crashed and it has landed back safely, that means you have very limited time. Just try to understand that, and your algorithm must be fast as possible, because then you can go run, you can begin your search operation as soon as possible. So this is where this problem comes very handy, right? And just think of it, it can come helpful in any different aviations related stuff. Right now I could only come with this, but if you have any other scenarios where this problem can actually make sense, you can let me know in the comment section, right? So what I'm going to tell you that we are going to maintain a minimum possible altitude, and we are going to maintain a maximum possible altitude, right? In the minimum possible altitude, what we are going to do is that we are going to assume that every corrupted signal is going to hurt us. It's very bad for us, and we are going to think negatively. Just think like that. And let's say that it's like a news. Every single news, you don't know if the news is good, bad, or something, right? So every single news, you just assume that hey, it's bad news. There is this guy. But there is a good guy also, right? There's a good guy which says that the good guy says that be optimistic. And that's what maximum possible altitude does. It is an optimistic thing over here. So every star, it says that I'm going to interpret it as a U character. So now the thing is that if the maximum, just take a note of this guys, if the maximum possible altitude ever drops below 0, that means the crash is guaranteed. Okay? Now, no, this is what I was going to tell you. Now, irrespective of all the different possibilities which you have considered, now in all these possibilities, if the altitude fell below 0, that means a crash would have occurred, right? In the maximum possible cases, think of it. And if the minimum altitude is 0 at the end, the drone, there is a chances, if the crash has not occurred, let's say that the crash has not occurred, and if the drone has landed safely back, then we know that the minimum altitude is 0 at the end, the drone might have landed safely. Yep, so this is our given intuition. Let's see how we are going to interpret all of these signals. So what we are going to do is that every time we encounter a signal, what we are going to assume is that, not even assume, it's deterministic, that the drone went up. So no matter what, both the best cases and the worst cases must go up, right? So your minimum altitude will go up by 1 and your maximum altitude will go up by 1. Therefore, when we encounter U, we are going to assume this following scenario. So it actually makes sense also, and I'm going to even show you with an example, right? And with interpreting the signal D, what we are going to tell is that this is the worst case. I mean, both the minimum altitude and the maximum altitude are going to decrement by 1, and that's what we are going to do over here, right? Now, what does minimum altitude means? Minimum altitude is just an indicator, right? It's the worst case altitude indicator. We might be at so far telling us, and it assumes that every signal, every corrupted signals is working against us. So this is what the minimum altitude, and it represents the lowest altitude this drone could possibly be at if everything goes wrong, right? Now, my question to you is that what if the minimum altitude goes negative? Now think of it like this. It means that in one of the interpretation, the drone has gone below ground. The drone would have gone below ground. But this alone is not a failure, right? This alone is not the failure, because remember our original question was that whether the drone could have avoided a crash or not. I mean, I know that I have not specifically I asked you this question, but what I meant to say over here is that we want to be optimistic. We are thinking in the terms of our optimism. So, and the only way to check if the drone has never crashed is using the maximum altitude. And if the maximum altitude is greater than 0, then it means at some interpretation, the crash could have been avoided, right? The crash could have been avoided and our drone could have been possibly saved. Okay. Now, what if the maximum altitude goes negative? So this is the exact case which I was telling you earlier. So this means the drone has definitely crashed no matter what. If the maximum altitude was your best chances of survival, right? It was your best chances of survival. Think of it like this. That means the drone has crashed and you cannot do anything, right? So this was all about the given problem. I hope you understood. Now I will start with a given example to explain you. But before that, I'm going to share one homework with you guys so that you can do after understanding this given problem. Now, coming to the answer, if the minimum altitude remains 0, that means there could at least, this is just a basic example, right? So now coming to the answer, you just have to check if the minimum altitude remains 0. That's all, right? And the homework is this one. Is the drone possibly still in the air at the end? You have to tell me that. Now, originally we were calculating if the drone might have even landed safely and it has never crashed. Now you have to tell me, is there a possibility that the drone could still possibly be in the air? So this is just for your sake. Now I'm going to explain you a given example. I think so. I might have erased it. So no problem. So let's say that we have an up signal, we have down signal, right? And we have a star signal, right? And again, we have up signal and we have a star signal over here. Let's take this basic example at this point. Now, can you tell me whether the drone could have survived this or not? Let's start explaining within our minimum and our maximum. So the minimum year and the maximum year, we will begin with 0. Both are beginning with 0. And this would mean that the minimum, once we encountered a 1, it would mean that minimum would have gone up, right? By 1, and the maximum could have gone up. So this is actually deterministic, guys. Think for it. When you start it and you receive the signal up, that means your minimum altitude and the maximum altitude both will be 1, right? And let's say that you encountered a down signal. That means ki you're going to decrement it, so the value will become 0. Now there is a star signal. The star signal can say that it can be either be interpreted as a 0, or it can it can be either interpreted as an up signal or down signal, or we can choose to ignore it. Let's say that there are 3 different possibility: up, down, and star. That means ignore. Now, what are the different range which is possible, guys? Try to understand. Now, our initial max and min from the previous state was 0, 0, right? You can understand this clearly. Now, if we take the up case, the maximum altitude will be increment by 1. If we consider that the star was negative, that means it could have gone to ground, right? It could have gone to ground, it could have crashed. And if we choose to ignore it, it means that there could have nothing be happened, right? So this is what exactly it is. We need to ignore these kind of statements. We need to ignore all the negativity in our life. We need to say that, hey, I know there exists a possibility where the drone could have gone negative, but we don't want to consider it. We want to consider it that if there is a negative sign, I'd rather be optimistic. See, there are 2 different possibilities, right? It could have gone to -1 or it could have gone to 0. So we choose the latter one. We say that, hey, I know the drone could have gone down, but I want to stay on the altitude. I want to consider a possibility where the drone could have been on the ground itself. So that's why we're going to mark it with 0 over here and up with 1. Now at this point, we know that the drone could have gone up again. So minimum altitude will increment by 1 and the maximum altitude will increment by 1. That will become 2, sorry. So now at this point we have another star signal, right? This is the star of the game. And again, same thing can happen over here, guys. Again, same thing. Let me erase this so that we can begin thinking again. So when we encounter the star, what could have happened is that the star could have mean down operator, or the star could have mean an up operator, or star could mean nothing, which I'm going to indicate like this. So if, let's say, a previous state, we know that the drone could have gone to maximum height of 1, and the drone could have maximum height of 2 and the minimum height of 1, right? So if we had considered down signal, right, if we had considered down signal, what could have happened? The state would be 0 and 1. That means the range at which the drone could have been is 0 and 1, exactly which we were looking for. And let's say that if the drone could have gone up, the range could have been what? Think about it. The drone could have gone up, and our minimum range could have increased to 2, and a maximum range could have increased to 3, right? And if we choose to ignore it, that means we just carry forward a previous state. So guys, don't you think, what is the range for this given problem? Like, you need to select the minimum from here. If we select the minimum from here, which is 0 over here, and if we select the maximum from here, which is 3 over here, eventually this actually represents the actual possible range of the drone at the last level. This would be 0 and this would be 3, right? And if I can clearly state, if I can clearly state that, hey, if the range of the minimum is 0, that means there exists one possibility where the drone could have, this is why it is called minimum, because it tells us that the drone would have landed back safely. There exists one possibility where the drone would have landed safely and the drone would have not crashed, right? And let's say that there was no star over here. Let's remove this. So what could have happened here, guys? What this state would mean? This state would mean is that the drone would have not landed back, and it might be somewhere in the air, which was actually the homework. So yeah, this was all about the given problem, and I'm just going to code it for you guys. So let's start coding this problem, guys. So what could have happened over here is that we're going to take the minimum altitude as originally presented, and we're going to assume to be the 0, maximum altitude to be 0, then going to keep iterating with I less than equal to s dot size, and we're going to increment this. After that, whenever we detect an opening bracket, we're going to treat it as a up sign. So our minimum altitude, I think so I need to copy this badly, are going to increment by 1, and a maximum altitude at this point will also increment. Else, if the s of I is equal to close, that means the bracket is going down. This would mean the minimum altitude is going to decrement and the maximum altitude is going to be decrementing as well. Now, if that's not the case, what can happen is that we need to increase our range, that means at this point, we have a noise, that is a star. That is, we need to take the minimum altitude and we need to decrement as well, but the maximum altitude we're going to increase the range, right? And what is the final thing? If the maximum altitude, let's understand, if the maximum altitude falls below 0, we can return false over here. Otherwise, we need to cap our minimum altitude. So let's say that we can just say minimum altitude is minimum, not a minimum, but maximum of minimum altitude and maximum. And after, at the end, what we're going to do is that if the minimum altitude, which I can again copy paste, if the minimum altitude is equal to 0, we just return. So guys, this is all about the given problem, and if I try to run it, I think so it should run calmly and smoothly. So the reason it works perfectly is that we are going to treat, so this given problem, I'm just going to change it, right? I'm going to just change this problem. This means now is कि जो opening bracket है, that means up signal, closing bracket is down signal, and this is a noise. Now what you have to eventually say is that does there exist any sequence where eventually this valid parenthesis string actually makes sense? If there is any valid parenthesis which is possible, and that can be only possible if the minimum altitude is actually equal to 0, right? The minimum altitude is actually equal to 0. That means all the opening brackets, all the closing brackets will eventually cancel out each other, and a minimum altitude, and there will exist a minimum altitude of 0. Otherwise, what could happen is that if the maximum altitude is less than 0, that means there is an imbalance which has happened, right? There is an imbalance and there is no way you can help it out. So that means you need to return false in that case, right? And just remember to cap this minimum altitude in all the given scenarios, which will be very helpful to indicate. So that's all, guys. I hope you enjoyed the problem, right? So give a like, thumbs up, and share with your friends. You guys, so that Oh, I even forgot the original problem. So yeah, this was the original problem which was said to you. So minimum altitude